While there is a common narrative that artificial intelligence is rapidly approaching human-like intelligence, this is a significant misconception rooted in misunderstanding what current AI systems actually accomplish. Many tout AI as edging toward artificial general intelligence, AGI, the idea that machines will soon think, learn, and reason like humans. However, the reality is far more nuanced and reveals fundamental limits in what these models can truly do. First, much of the hype hinges on the impressive scalability of large language models like GPT-4 and Llama 3, which are trained on hundreds of billions of tokens amounting to datasets in the tens or hundreds of terabytes. Yet despite these vast datasets, these models are primarily pattern recognition tools that operate on statistical correlations within text. They lack genuine understanding, reasoning, or consciousness, attributes inherently tied to human cognition. Simply increasing data and model size does not equate to developing true intelligence. It often results in more sophisticated pattern matching, but not deeper comprehension. Second, there is a widespread misconception that humans learn from fewer samples than machines. In fact, human brains are immersed in an enormous flow of multimodal data daily, estimated at about 34 gigabytes of information each day, including sight, sound, touch, smell, and taste. Over a decade, this accumulates to more than 80 terabytes of integrated sensory input, far surpassing what even the largest AI training datasets encompass. Our learning process is based on rich, interconnected, embodied experiences, not isolated data points. We actively interact with our environment, continually receive feedback, and develop abstract reasoning capabilities. In contrast, current AI systems primarily process unimodal or stitched-together multimodal data without genuine embodiment or active interaction. Third, human cognition benefits from hierarchical, symbolic, and contextual reasoning, built upon a lifetime of interconnected experiences. This complex internal modeling enables us to generalize from relatively few examples, something that current data-hungry AI models cannot replicate. The key isn't simply more data. It's how that data is processed and integrated into a meaningful understanding of the world. In summary, the myth that AI is on the brink of human-like intelligence because of impressive datasets and compute power is misleading. Real progress toward genuine intelligence will require architecture that can process multimodal, highly contextual, and embodied data more akin to human cognition, rather than just scaling up existing models. Until then, AI remains a powerful pattern recognition tool, capable of astonishing feats, but fundamentally limited in its capacity for true understanding and reasoning.